Καλή σας ημέρα. Καλώς ορίσατε στο Athens Science Virtual Festival 2021. Είμαστε εδώ για δεύτερη μέρα σε ζωντανή διαδικτυακή μετάδοση από το ανακαινισμένο αμφιθέατρο της Τεχνόπολης του Δήμου Αθηναίων για να αναδείξουμε τις πιο σύγχρονες εξελίξεις σε τομείς της επιστήμης, της τεχνολογίας και καινοτομίας, αλλά και τη σχέση της επιστήμης με την τέχνη. Θέλουμε και σήμερα τη δυναμική συμμετοχή όλων σας. Στείλτε μας την άποψή σας, τα σχόλιά σας, τις σκέψεις σας και οτιδήποτε θέλετε να μοιραστείτε μαζί μας στα social media του Athens Science Festival, στο Facebook, στο Twitter και στο Instagram. Σας υποσχόμαστε μια εξίσου ενδιαφέρουσα δεύτερη μέρα. Η εποχή των ηρώων είναι εδώ. Ας την εξερευνήσουμε όλοι μαζί. Το Σεπτέμβριο του 2019, το γερμανικό ερευνητικό παγοθραυστικό Polarstern απέπλευσε από την Νορβηγία για να περάσει έναν χρόνο στο Αρκτικό ωκεανό, παγιδευμένο στον πάγο. Αυτή θα μπορούσε να είναι η αρχή ενός ωραίου θρίλερ. Στην πραγματικότητα όμως ήταν η αρχή της μεγαλύτερης στην ιστορία αποστολής στην Αρκτική, της αποστολής MOSAiC. Στόχος της ήταν η βέλτιστη δυνατή παρατήρηση της Αρκτικής από κοντά, για την απόκτηση απαραίτητων γνώσεων για την καλύτερη κατανόηση της παγκόσμιας κλιματικής αλλαγής. Υπεύθυνη για την ασφάλεια του τεράστιου και εξαιρετικά φιλόδοξου αυτού εγχειρήματος ήταν η Verena Mohaupt, συντονίστρια πλατφορμών εφοδιαστικής και έρευνας στο Ινστιτούτο Alfred Wegener της Γερμανίας. Ανάμεσα στις ασυνήθιστες αρμοδιότητές της ήταν να εκπαιδεύσει τους εκατοντάδες επιστήμονες που συμμετείχαν στην αποστολή σε θέματα ασφάλειας και επιβίωσης. Από το πώς να αποδράσουν από ένα ελικόπτερο που έχει συντριβεί, πώς να αναειριχηθούν στους πάγους για να διαφύγουν από τα παγωμένα νερά, μέχρι και πώς να αντιμετωπίσουν τις πολικές αρκούδες που τριγύριζαν το παγοθραυστικό. Η Verena Mohaupt είναι εδώ, στο Athens Festival Science, για να μοιραστεί μαζί σας τις μοναδικές της εμπειρίες, αλλά και πώς τα πολύτιμα δεδομένα που συλλέχθηκαν στη διάρκεια της αποστολής MOSAiC θα οδηγήσουν την έρευνα για το κλίμα σε ένα εντελώς νέο επίπεδο. Ας την ακούσουμε και ας ελπίσουμε πως ούτε το φινάλε του έργου θα είναι θρίλερ. Τη συζήτηση συντονίζει η Ασπασία Δασκαλοπούλου, περιβαλλοντολόγος και δημοσιογράφος επιστήμης.
Κωστή, σε ευχαριστούμε. Καλημέρα σας και από μένα. Good morning, Verena. Thank you for participating in our event. It's a great honor and pleasure to have you here with us. Please give me a minute to introduce you to our audience and I'll be back with you shortly. Είναι μεγάλη μου χαρά και τιμή να καλωσορίζω σήμερα στο Athens Science Festival μια επιστήμονα που συνδυάζει δυναμικά τους ρόλους της ερευνήτριας, της εξερευνήτριας, αλλά και της επικεφαλής ασφάλειας μέσα αποστολή στην Αρκτική, που και οι πιο τολμηροί θα δίσταζαν ακόμα και να φανταστούν. Το επιστημονικό περιοδικό Nature ξεχώρισε τη Verena Mohaupt ως μία από τις 10 προσωπικότητες που βοήθησε στη διαμόρφωση της επιστήμης το 2020. Στην ίδια λίστα, ο Γενικός Διευθυντής του Παγκόσμιου Οργανισμού Υγείας και η επικεφαλής έρευνας για την ανάπτυξη των εμβολίων της Pfizer. Ωστόσο, έχοντας επομιστεί την ευθύνη να διασφαλίσει την επιτυχία της μεγαλύτερης και απαιτητικότερης επιστημονικής αποστολής στην Αρκτική, η αναγνώριση αυτή ήταν φυσικό επακόλουθο. Η Verena Mohaupt, τόσο κατά την προετοιμασία όσο και κατά τη διάρκεια της αποστολής MOSAiC με το γερμανικό ερευνητικό παγοθραυστικό Polarstern, διασφάλιζε σε εκατοντάδες ερευνητές από 20 χώρες την ευκαιρία να μελετήσουν για πρώτη φορά τις επιπτώσεις της κλιματικής αλλαγής καθ' όλη τη διάρκεια ενός έτους, συμπεριλαμβανομένου του απροσπέλαστου αρκτικού χειμώνα. Στην ομιλία της στο Athens Science Festival, η Verena Mohaupt από το Γερμανικό Κέντρο για την Πολική και Θαλάσσια Έρευνα Helmholtz θα μας ταξιδέψει στους πάγους της Αρκτικής, εκεί όπου η κλιματική αλλαγή αφήνει καθημερινά το καταστροφικό της στίγμα. Περιμένουμε τις ερωτήσεις σας για την κυρία Mohaupt στο πεδίο κάτω από το βίντεο. Mrs. Mohaupt, welcome again, and we are all ears.
Hello. Yes, thank you. It's nice to be here. Thank you for having me. And okay, I guess I'll just start and talk a little bit about the expedition I was on. So, how do I do that? There. MOSAiC, there we go. So it was the biggest Arctic expedition up to date. It was year-round, in total 389 days, more than 80 institutions from over 20 nations, 337 scientists and experts, and 105 crew members were actually in the field, and several hundreds more were involved on land. We had 5 scientific teams and 5 support teams. 70 metric tons of equipment and 247 monitoring stations, just a little bit to show you the scale of operations. But I get a little bit back to what was actually the idea behind it. Why did we do that? So the Arctic is a key area for global climate change. As you can see here, it's really getting hot in the Arctic over time, and way more than in other areas of the world. And this warming in the Arctic, it's most severe in winter time. So this is the annual mean temperature rise, and this is actually just in winter. So you can see in winter in the Arctic, and that is a station that is located on Svalbard. It actually is +3 degrees per decade. That's nearly double as much as in the rest of the Arctic, in the rest of the year. And also the sea ice, yeah, it's decreasing a lot. And in this graphic, you see this is the models and the predictions, and that is actually the measurements. So it's even way worse than the model set that it's going to be, which is a sign that the Arctic climate change is not very well represented in these models. So here we see some graphics of the sea age, and that's also been happening over the last years. The Arctic before, it's not like the Antarctic, so it's not a continent, whatever, it is only sea ice surrounded by landmass, but it used to be ice mass that is multi-year ice that is a couple of years old, and this is decreasing, so we come more and more to a state where it's more fresh ice, and that is only first-year ice. So here's just again models for climate change and climate projections, and you can see all these different models, they have uncertainties, and in the Arctic, these like all these different models for the Arctic, they vary the most. So all these models, they don't really show really what's happening in the Arctic. There's a huge uncertainty, but the Arctic, there we go, we can see the model spread. This is all the different models, and here they kind of, all right, they nearly all say a little bit the same, and here they really differ a lot. Yes, it's only very roughly presented. But if we want to understand the general climate processes, then we need to know what's going on in the Arctic, because the Arctic has this extreme role, and it plays a role for the whole global climate. And if we want to understand that better, we need to understand the Arctic better. And to understand the Arctic better, we actually need more observations, because there is just a very limited set of observations all around the world. There's monitoring stations all over, but in the Arctic, well, at certain times of the year, it's kind of hard to get there. So there's just not as much. And in general, there's not as much people. So the idea of MOSAiC was basically reaching the central Arctic in winter to also have more data from this area, especially from winter time. And we basically, I actually jumped on board. That was other people that had this brilliant idea, but the idea was copied from Fridtjof Nansen, who had the From expedition 1893 to 1896, where he went up to the high Arctic and had his ship frozen into the Arctic sea ice and drifted with the sea ice. And MOSAiC tries the same. So we wanted to go with a ship up into the high Arctic, set up camp with our vessel Polarstern, pretty much like Nansen, just a bigger boat with more people and way more instruments. They did do some science back then as well, but well, it was a different scale of things. And then drift. So we set up a camp on the ice with lots of measurement station and drift with the sea ice, through the ice, completely in the hands of the ice and nature, and measure throughout that whole time. In order to get refueled and get food and everything, and also to exchange people, there would be visits from other icebreakers from MOSAiC partners. And it would also be linked with aircraft and helicopter operations, and of course, satellite data as well. So that was the idea. That's what we wanted to do. That was the plan. That's how it looked like sometime in 2019. We would start in September 2019 from Tromsø, together with the Russian icebreaker academic Fedorov, who would actually join Polarstern into the ice to find a suitable ice flow and bring more people in this very hectic time to set up camp, because time is very limited up there. The polar night is approaching, and of course setting up camp is and finding the ice flow and all of that is way easier when light is still around. And also, yeah, so to get all that done in the extra in this time, we needed some extra pair of hands. And also the Fedorov main task was to set up a so-called distributed network, which was literally autonomous stations around the flow. Once we found that flow, that would measure autonomously up to 50 kilometers away from that central observatory. And yeah, so we needed an extra ship for that. So those ships left in September 2019. And then there would be 6 cruise legs. And the exchange of the crew and like supplies and everything would be done with other icebreakers. So that would have been, again, 2 Russian icebreakers, or twice the same Russian icebreakers in mid-December and mid-February. And then because it's getting really hard actually to travel through sea ice in deep winter, the ice gets thicker and thicker, and that is not, it's getting more and more easy for ships. I mean, we hear more and more, we hear about vessels going through the Central Arctic to record times, and then whenever that hasn't been possible before. But non-nuclear icebreakers through that area in the middle of like winter when the ice is thickest, that is still quite hard. So in order to make sure that we can have an exchange, then the plan was to do this exchange with Antonov airplanes. And so we had to build an ice runway. And then again, in mid-June or in summer, that would have been the next exchange. And in mid-August, the last one with a Chinese icebreaker. So that was the plan. You'll see later, the plan got scrambled around quite a bit. Yes, this is just a small image before we actually started. I mean, there was years of preparations. I think 11, 12 years before we actually left Tromsø, the first idea was born and the planning started. So this took nearly a decade or over a decade of preparation. Of course, to kind of get money, like get through to the bosses of the institutions and to get funding and all of that, and to get everybody on board and to have a proper science plan and to get the logistics sorted. That was one thing, but also to do all this planning like this one. So this is a simulation of lots of buoys. So there's a lot of researchers that put buoys out in the sea ice since years. So they have buoy tracks from the last years. And this is literally, how does the ice normally move? So we have a certain prediction of how does it normally do. Of course, then this is all statistic. That's why I said drift statistics. But based on these statistics, we chose our target area. It's like, where do we want to go to have the best chances to end up where we want to do. So it's like not to go too far south, to not to drift out of the ice too quickly, not to go too deep in, because this Fram Strait actually it parts at some point. So we wanted to go basically around the North Pole and then out somewhere between Greenland and Svalbard. Otherwise, if you turn left, then you go towards Canada again. It's maybe nice if you want to go in circles for years, but it's not what we had planned. So yeah, there's all this to take into account, and the sea ice physicists, they did a really good job in kind of, this is the area what we aim for, and we have to look for a flow in that area specific. So in September we left. So here you see Polarstern and academic Fedorov in rather thin ice. This is actually when we had some cargo handover for a couple of hours. So they left together from Tromsø, and we went into the target area, and the first big task to do was to find the right flow. So you see the drift track of the two vessels. They met, and then, yeah, Fedorov went here to set up all this this network with all the buoys, and we had a couple of meets where we handed over cargo, and also people were exchanged, and then at some point, only the ones that actually stayed the whole 3 months, they stayed, and the rest went home with Fedorov mid-October. But yeah, so to find this flow, that wasn't that easy, because the ice in the area was, we did several measurements and checked several flows. There was helicopters being used. Again, that's why we still needed daylight. Can't really fly that easily in polar night. And satellite images, and all this then was probed and measured, but a lot of the ice was 30 to 70 centimeters thick and rather rotten, not really stable. And it was kind of clear that this is not really what would last us throughout the year, and what would be potentially have, yeah, would be stable enough to drift all the way through, and also to be able to carry. We had these huge piston bullies that we needed to later on build the runway, and a lot of other equipment, and there was a lot of fear that this might just not be big enough. So this is just one satellite image where you see this is then, again, it's not my job, luckily. It looks a little bit like ultrasound. It's really, when you're not trained, it's really hard to see anything on these images. But so this is the green circles, is potential ice flows that were also scouted. And then this was in the end the special flow, and it really was special because it was that one that was standing out, that was different. It looked strange in the satellite, and then we went there and we checked it out. So it was, yeah, 3.5 to 2.5 kilometers wide, and it was special in the sense that it had this structure in the middle, which was very ridged, and that was very stable. So yeah, we went there, we checked it out, we measured, we drove around, and it was chosen this is going to be our flow. And in the process of setting up camp and exploring this ice flow, this thick part here that was in parts where the ridges were like really had built up over the years, or the last year at least, that was called the fortress in the end. Yeah, so oh, I skipped a slide. Yeah, so once that was chosen, it was time to set up camp. So around Polarstern, you can see in the bottom left, there's Polarstern, and from Polarstern onwards, we were setting up a network, the so-called Central Observatory, with different hubs for research instruments, and each of those hubs was connected to power. So we had to build a network of power cables and power lines on the ice. Certain equipment was flown out with a helicopter, as you can see in the bottom right. Certain of these hubs also, so we had different teams on board. There was a team eco that was more looking at ecology. There was an oceanography team. There was a sea ice team, and there was a BGC team, biogeochemistry, and all these teams, and an atmospheric team. And there was an MOSAiC, which basically consisted of one power hub and lots of atmospheric instruments. They had a 12-meter tower and even a 30-meter tower just to measure throughout the first layer of the atmosphere. There was a place called Remote Sensing Town, or well, everything got to town or a city at some point, but it was a lot of strange instruments that were measuring remotely, and those are actually used to compare with satellite data later on, because the satellites do measure the Arctic continuously, But now this expedition gives comparison data. So now we have basically instruments that also measured on the ground, and now they have better comparison to what do the satellites see, what do we actually see on ground, and how can we then use the satellite data in a better way. We had Ocean City, which was basically a big hole in the ground, a bit like this one. And Rove City, where they also made a big hole, or where they deployed a little robot all the time. So through these holes, they were measuring the ocean and what's happening underneath the ice. Yeah, and then we had lots of teams that sampled all around, but setting up camp, that was the first major priority. So yeah, this is one of the holes, and here you see, actually, this is one of the power hubs. They were about 750 kilos, so they had snowboards underneath to push them also around, but they were much easier to move with a helicopter. Yeah, and as said, yeah, so 100 tons of scientific equipment and a lot of stuff. And Polar Night was approaching, so we had to be quick. We had about less than 2 weeks to really set everything up. And then the measurement started, and we just stayed there and measured throughout the winter. So here at the bottom right, this is what the remote sensing site looked like. So all instruments were supposed to be on sleds, because you'll see later, it did happen that we had to move stuff, and all these are quite heavy. They're all a couple of 100 kilos. But if it's on sleds, and if it's flat there with the Ski-Doo, or even with manpower, you can move quite a lot. There's a bunch of people and ropes. It's it's surprising how much you can actually get moving. So this is the Atmos city from a bit further away. So you see the two towers, and then there's actually a bunch of instruments below them. The left tower is 30 meter high, and the right one is 12 meter high. And all the small instruments below, you don't even see on that picture, but there was a lot of them around. And then the big tents at the bottom left, this is one of the tents that was set up over one of these holes to kind of keep it from refreezing, and also, well, to make it a little bit nicer to work on that, because it got really cold in winter. So this is a nice time-lapse video that shows the first weeks during setup until the light fades out. And then also this video, we had a camera installed high up. So it gives a really nice impression. Also, we didn't build a city or a camp on land. This was on ice, and ice is very dynamic. So one thing we had to fight a lot, especially during the first leg, was ice movements and breakups of the camp. There's some more pictures later, but I'll just show the video, and I hope this works. So this is to the bow of Polarstern, and you can see these little people running around. We start with basically a blank sheet, and then, well, we explore some more, and we put out ice anchors, and you'll see more and more equipment, and people go explore and find their sites where they want to set up equipment. First couple of days, it was literally just exploring, and then we had lots of meetings to divide, like, who gets which part of this flow, and who is maybe clashing with another group, and which instrument can't be too close to that one, because maybe they all have things in the ocean that might get entangled, and all that sort of stuff. And you can already see the first crack forming, and then you see the first power line going out, and like little ants running around and setting up stuff. A crane sometimes moving out and bringing out more stuff. You can already see how the light fades out. So the thing with leads is it opens up, and that can actually happen already quite quickly, that it moves, and it really moves meters out. And then all the same site, it can also kind of come back together and crash back together. And then you have these ridges forming, and they basically eat up everything that's in their way. So here, right next to the lead, that was our Rove site, where the ROV, that's a remotely operated vehicle that's operated under the ice. So they have a big hole, and then they set up this tent, and they want to dive under the ice. And they set up all their camp. They had a power line and everything, but there was this big lead, which was very worrisome. And well, you will see it didn't last very long. So already a couple of days later, the power line was eaten by the ice. So we had to try to get the cables out of there and move everything, because that wasn't an ideal, that wasn't stable. Well, stable enough to go over or whatever, but it kind of ate the power cable. So we had to move the power line, and then new cracks formed. So given that the ice was still very thin, this was still very dynamic. And it actually got more dynamic throughout winter, but the video stops at some point because we don't have any daylight anymore. Yeah, so but you get a good idea on why time was precious, and also how things moved around. It was quite impressive. Yeah, so now I think it's only black. I'll just go to the next slide. Yeah, so we're quite far off everything. The next settlement is over 1,000 kilometers away. And once Fedorov was gone, we were on our own and in the hands of nature. And the drift, well, the engines were off. We were anchored to the flow, and we just followed wherever the ice wanted to go. It was very cold. It dropped to around minus 30, minus 40 degrees. And when you then have wind, then it actually feels much colder. And bare skin is, it can freeze very quickly. So one thing is really to cover up as much of your face as you can, and to look out for one another to see if there's maybe some frostbites forming. That's really important, because you might not even realize yourself, but that's why you have your buddies and you always check, are you all right? We had a lot of storms, especially during when there was a lot of very stormy days. That made hard work on the ice quite hard. And well, as you can see on the first picture up left, visibility is real bad when there's a lot of snowdrift, especially in the dark. Even with headlamps, it gets really hard to see past this first wall of snowflakes that you just see. And also a lot of storm means even more dynamics in the ice. So we had a lot of breakups where suddenly we had to cross small cracks in the ice, or the ice moved and pulled on the power cables. That's why this power hub that you see at the bottom right is actually flipped over, because the ice had moved and just pulled the cables, and they were attached to the hub, and it just flipped it all around. So we had to find ways to flip that one back up, 750 kilos. It wasn't that easy, but we got it back up. Yeah, so cracks and leads open again and again. They also close again and they refreeze again. So that's just how it is up there. They are very often, it can also happen that it kind of opens up and then it shears. So it's not just that it goes like this, but also sometimes it just goes in different directions. And this happened on like one particular, so that was, it's just, well, it's what we use to kind of orientate ourselves on this flow. This was the sketch we had, and you can see that's what happened. So that happened end of November. And you can also imagine at that point, well, certain sites had to be rebuilt, and also the whole power line system and everything, you have to basically start again. So yeah, I definitely can say it was never boring. Every day something new. So this is the ridges, and you can see at the bottom right, this is what you've seen in the time lapse already. So this is where they're trying, or where we are trying to get this cable out of there. And it's actually quite hard. You normally end up with cutting the cable, and then once the plug's gone, you can pull it through. And also this at the bottom left, this ridge formed just maybe it was 15, 20 meters away from one of the sites that we had. And we were all very afraid that this might actually eat up the tent. So this was continuous monitoring. Is there more cracks? Is there movements and whatever? And of course, polar bears. We had in total more than 60 bears visit the MOSAiC ice camp, and a lot of encounters. So this is the home of the polar bear. And of course, we try to, well, we don't want to harm them, and we don't want them to harm us. So we had polar bear guards present whenever people were working on the ice. That was my job, mostly while I was actually in the field as well, just make sure people are safe from polar bears. But they are lovely creatures, and actually every encounter was great. It was just great to see them out there. So mid-December, the Kapitän Dranitsin was in the end another boat, but they came at the end of leg one. So I left the flow with Dranitsin, and it was quite a special sight to see this other ship approaching from out of nowhere in this darkness, suddenly there was just light at the horizons, and then there was another ship. So that was a very special moment. We handed over a lot of cargo, and then I left. But of course, the expedition went on, new participants, new teams. So leg 2 and 3, it was very cold. I think they had the coldest temperature on leg 2. It was minus 43 or something. They had to build this runway because the ice was finally thick enough, and they really had to prepare the runway. So they were starting with that, and you can see these big machines that were there. And as I said before, the runway and why we wanted to do that. So already in February, when the Kapitänstjänsten came up another time for the exchange between leg 2 and 3, it was a big challenge to make it through the ice. So they actually struggled a lot. They were a bit delayed. They used longer than they thought. In the end, we had also to send up another Russian icebreaker to refuel them so that they can really push with all force, because that's the thing when you break ice. That I learned, at least on the voyages I've been on. It's like very often they move so slowly. They go on top and they kind of break it a little bit, and then they go back and they ram in. So through thick ice, when they do that, that takes ages to go, maybe even just a couple of nautical miles. So they were, I think, in total 3 weeks later than planned, but they did make the exchange. And you see at the bottom left, this is the second exchange between Tromsø and Polarstern. That time they were a bit further apart. And actually these machines that you see in the bottom right, the piston bully, they were then also used to bring all the equipment and cargo from one ship to another. And of course, you see also on the bottom left, that's already beginning of March, the sun comes back. So that's the end of polar night, and the sun comes back. And the third leg then had, again, a lot of cold, but daylight. And yeah, but then Corona happened. So yeah, beginning of March, that's where the rest of the world had, yeah, we had our own biggest thing ever, or at least what I had in my lifetime. And it also, you've seen the planning before, it literally scrapped all the plans. None of that was feasible anymore. International travel didn't happen anymore. We couldn't fly people from, I mean, we had participants from all over the world that needed to come to Tromsø or to Longyearbyen actually to fly. None of that was happening. Airports were closed, nothing worked. Institutes didn't, like the Odin and Shillong, they couldn't just go, like ships had restrictions. So we really had to, had so many meetings to figure out how can we make this work. Like we have a team out in the ice, and this is a once in a lifetime experience, or like this expedition, we put so much effort, and if we can't abandon it now. So like there was so much motivation to keep this going, and we did find a way. But yeah, it was a lot of back and forth, and I think I can't really remember how many options we had on the table. And it was so often that we thought in the evening, like, okay, now we have an option that we can communicate to the people in the field, like, and everybody, this is how we're going to do. And just hours later, it's like, nope, not going to work. But it worked. So leg 3 in the end lasted about 8 weeks longer than planned. We had a medevac flight for some people that really needed to leave because of medical reasons. Of course, then, yeah, one makes everything possible to get them out. And we have some very capable people in the institute that I don't know how they did it. But so we had a small flight on this runway that was prepared, even though it also had broken up in the meantime. But there were some small planes coming from Canada via Station Nord in Greenland with lots of restrictions. And they brought a couple of people away from that. And then the rest, we found 2 German vessels, Son and Marian, which unfortunately didn't have the ice class to go into the Central Arctic. But it was the only vessels we could find for so many people leaving from Germany. We all had to quarantine. I jumped back on board then for leg 4. So we had to quarantine 8 days of really single room and being tested and poked in the nose and all of that. And then I think in total, it was 16 days of quarantine. But we made it, and we had it exchanged in the fjord in Svalbard. So Polarstern, actually, they kind of took everything that was in danger, and they only left remote stations, and they brought everything else on board, and they came out of the ice to Svalbard, and we had the exchange there, and then we went back into the ice. So the camp was alone, autonomous for about a month. But then we set up camp again. So there you see this rough hut again with a helicopter. We've started not at zero, but at the beginning again, and set up camp again. And that was in June then, and that was definitely melt season. So June, July was melt season. As you can see, it looks totally different in summer. Instead of snowdrift, now it's slush and meltwater channels. There's huge ponds everywhere. But it looks beautiful. It's also just way more blue and way more colors. It's not just white, and there's so many different sorts of blue. We started again with making big holes in the ice to see what's happening under. And all the scientists were really excited about that, because this is now what's happening there. The ice is melting. How is it affecting? How is the snow disappearing? How does that affect all the other things? And what's the ecosystem doing now? And yeah, so it was really good that we could still be there. And we set up the tower again. See there, the 30-meter one, that wasn't possible anymore, but the 12-meter tower was up and running again. And yeah, so this is you see some nice pictures. On the left, we had tethered balloons at the flow as well. So this is actually a camera attached to one of the tethered balloons. This is, I would say, maybe 2,000 meters up. Looking down on the flow also got a lot smaller. Like already at the end of like 3, there was a lot of movement again, and in the end, only this stable core stayed. So it grew a lot during like 1, 2, and 3, and then by the end of like 3, it got dynamic again, and it moved around quite a lot. So when we came back for like 4, we were back to a maybe 2-3 kilometer wide flow. But then by the end of July, we had drifted very far north, and we were quite close to the ice edge. We had these daily meetings and like monitoring everything. And at some point, it became clear that like we started feeling the first bits of swell. So that's when you come close to the ice edge, the movement in the ice, you don't actually have waves or anything or swell, because the ice is stable and blocks that. But when you come closer to the ice edge, then the swell comes more in, and that is what breaks up the ice then. So we took down the camp 2 days. There was like the decision, okay, we start feeling little bits of things. We need to take down stuff now. And it was actually the last bits were off the ice, and in the night to the next day, everything, like when we woke up the next morning, there was just pieces left. There was no big flow anymore at all. So that was it. Yeah. And you see here, this is also one of the machines we had to pull things over the ice, and it was more bumpy with all the melt ponds. So we have a lot of people here. Their only job is just to stabilize that. Yeah. But the expedition wasn't over yet. So we wanted to see freeze up. So we actually went back north to complete the annual cycle. And we went over the North Pole actually, and then went back into the target region and find another ice flow to capture what's happening when the Arctic freezes up again. So that was an extremely beautiful time. So many nice pictures, and you can see scientists now. We still wear survival suits, but we walk through the melt ponds, and they measure what's happening there, and it's whiter again, but it's still this very blue and the most beautiful light one can imagine. So again, the tower goes up again, holes in the ice, all of that. And you see, this is when then when cracks open and there's a thin layer of ice on top of it, and then it moves and goes together. Then you have this crizzle crazzle of ice and snow, and then with this little ice flowers, frost flowers on top of it. And it's so beautiful. So this is this one thing. This is the ROV. This is this robot that goes under the ice, and maybe just a small impression on what it actually looks like under the ice. So this is the video from like 5. So you can see the ice has during summer, you can see it being eaten away from below as well. It's not just like blocks anymore. I mean, there have been ridges throughout winter and then even in summer, but then it kind of gets eaten away from underneath as well. There's so many shapes and different forms in there, and algae underneath the ice. Sometimes it's very flat, and you can actually also see the melt ponds kind of coming down and the different structures. And I was quite amazed on, I don't know if you can watch this video now the full length, but there's in darkness, this is one of the measurement sticks that they put in the ice to orientate themselves, because otherwise it's really quite hard to get the same, they want to do repetitive measurements, so they had the same track that they went every time as well. And you see fishes, and there's seals under the ice, and in polar night you could see some transluting, light-emitting little jellyfish, and it's really beautiful. Maybe just because everybody loves polar bears, so maybe the last little video we just look for a minute at some pictures of polar bears, and that would be it. So this is a video a colleague made. She's a photographer, and this was one of the most precious moments, I think, on my tour. This was the youngest bear I've ever seen. It was really cute and really small. So she was visiting the camp with her cousin. She was quite close to the ship at that point, but also my colleague, she had a really big lens and whatever, so I tried to take pictures. It's much better with those people that have the right equipment. So this is much lighter than but this is in the end we chased them away just with noise. Very often they don't really like noise, they are curious, but luckily they also don't really like noise. Also really nice. I was always in the bed. Okay, that was it. Thanks for your attention.
Thank you very much, Verena. That was so interesting. So beautiful videos. I can't stop smiling after the last video.
Yeah, it's very cute.
Yeah, we have just 3 minutes for questions.
Ooh.
But that's fine. That was so interesting. We didn't want to stop earlier and miss all these beautiful images and explanations. So yeah, being on this smiley mode, I was wondering if you could we could ask you a question about looking back now as a logistics chief. What has been the most hilarious situation that you had to deal with during this expedition? I mean, it might not have been hilarious back then, but
That's a very good question. Maybe there were so many little things that only came up then. For example, we had one thing was a misunderstanding between, I think, our purchasing department and me. And I ordered the drill, and what I got in the end was a concrete drill. That didn't work at all. It did not work. But so yeah, but luckily other colleagues had drills, and we had plenty, like we had enough drills, so that wasn't a big problem in general, but it made me smile for sure a lot. Yes.
Yeah, indeed. And also, I know that you were responsible for the training of most of the participants, if not all of the participants in the expedition. Mm-hmm. So, what was the most difficult thing for them to learn?
I would say maybe the general part of being out there. I mean, of course, polar bears is exciting, and the training to how to behave with polar bears. And then also we had a training where we taught them about sea ice, and then they had to actually go in the water, and the first 3 trainings were done in Tromsø. So they were actually jumping in the Tromsø fjord, which was already quite cold at that time, and they had to try the self-rescue technique. So that was, of course, logistically challenging as well. But in general, it was like we had so many different people, some with decades of experience in the field and in the Arctic, but maybe not in polar night, and others, it was their first expedition. So to bring all these different people, roughly, this is what we need to know, and this is what our rules are, that was maybe the most challenging, I think.
Very interesting indeed. Thank you very much. That was a beautiful journey to the Arctic, with all the difficulties and the very interesting results that we will start seeing very soon. Yeah, we have already started receiving information from this expedition.
Yeah, the scientific work starts now. I mean, the expedition is over, but I think the science outcome, that will be decades from now on. There's so much data. So
yes, cool. Yes. And if I'm not mistaken, in a few years' time, it will be free for everyone to use all this data.
Yes. Yeah.
Perfect. Thank you, Verena. That was lovely. Thank you for being here. And we hope to see you in person soon.
Yeah. Look forward to that. All right.
Bye-bye.
Bye.